Welcome to Ride On Academia. We are still on our series on differentiation. Today we are going to be looking at the partial derivative. Okay, we are going to be looking at how we can use our Lagrange multiplier in solving differential equations. The idea of the Lagrange is to help us find the maximum and the minimum when we are given a constraint on our input. Okay, when there is a constraint, especially that's even the basic. Okay, when we have a constraint, we want to see how we can use our Lagrange in solving differential equations. Okay, so we're going to be having partial derivative from those equations, and then we'll be solving simultaneously. So what we're going to be doing now, we're going to be taking an example, and then we're going to be solving together. All right, now we have that to meet the demand, a company must manufacture 40 units of a product in a week. So a company must manufacture 40 units. Okay, we have a constraint that they must manufacture 40 units of a product, okay, in a week. Now production take place in 2 assembly lines. All right, the total cost of manufacture can be calculated from the equation C is equal to 4x squared plus 6y squared then minus xy. Okay, this is the formula for our cost, okay, to calculate our cost. All right, now we have that x and y are the number of units produced in the first and second assembly lines. Remember, we have a constraint that the company must produce 40 units. Okay, and then we have 2 different assembly lines. So a particular assembly line produces x units, and then the second one produces y unit. Okay, but our constraint is that whatever unit produced in the first assembly line and that produced in the second assembly line must be equal to 40. All right, it must not be more than and it must not be less than that. It must. So this is our constraint. All right, now we are asked to determine how many units that must be produced in each of the assembly line to maximize the total production cost. All right, now like I said, we bring in our Lagrange multiplier when we are trying to solve and we have a constraint. Okay, now before bringing in our Lagrange multiplier, this is still our cost function, right? So the first thing I'm going to be looking at, I will be dealing with our constraint. Now we're going to be making our constraint. We want to equal this to 0. Like I'm going to be taking this 40 to this other side, bringing it to the left hand side. Okay, so that we'll be having an equation, like our expression will be equal to 0. Okay, so in doing that, we'll be having that x plus y minus 40, okay, to be equal to 0. Now with this, we can now expand our cost function. Then we'll introduce our Lagrange multiplier. Okay, expanding our cost function, we are still having our 4x squared plus 6y squared minus xy. Right, now we are introducing our Lagrange multiplier. All right, and then multiplying by this. Okay, so we are having x plus y minus 40. This is our expanded cost function. Okay, I'm bringing our Lagrange and then multiplying by this. All right, what we have is equal to 0. Okay, now we're going to be expanding this bracket. We're going to be having c should be equal to 4x squared plus 6y squared minus xy plus, now this multiplier will have our Lagrange times our x, then plus our Lagrange times our y, and then our minus. Okay, minus 40 and then our Lagrange. Okay, now the idea of partial derivative is that when we have gotten to what we're going to be doing here, we're going to be differentiating with respect to x, with respect to y, and with respect to our Lagrange. Okay, so the first thing we're going to be doing will be differentiating with our respect to x. Okay, like when we say with respect to x, that means we only consider the variables that has x, okay, in them. Just 3 variables in this case. All right, so the first we are doing, the power of our x is 2. All right, if you've watched how to differentiate, so 2 times 4, we're having 8, right? 8x, then 2 minus 1, we're left with 1. Okay, so x to power 1, we have x, so we have 8. Okay, 8x, right? There's no x here, so it becomes 0. Now there's an x here, but the power of our x here is 1. So when we differentiate, multiply, we have minus 1. Okay, but 1 minus 1, we are removing 1 from the power, right? Becomes 0. X raised to power 0 is 1. So the x here will disappear, right? We are left with minus y. And then our Lagrange, the x here is 1. Okay, minus 1 becomes 0. So we are left with plus our Lagrange to give us what? 0. I'm bringing 0 because our turning point, right? Our turning point, our equation becomes what? Equal to 0. So these are, and then I can also decide from here to make my Lagrange subject of the formula, okay? I can make that. So I'll be taking our Lagrange from here all over, okay? Or if I want, I will be taking this one to the other side, okay? So our Lagrange will stand alone. So what we're going to be doing is that our Lagrange multiplier, now when our plus 8x goes over, it becomes minus 8x. And then when our minus y goes over, it becomes plus y. So I can call this our equation 1. Right? This is our first equation. Now we are differentiating with respect to x. So the next thing I'm going to be doing is I will be differentiating with respect to y. Alright? Now with respect to y, alright, with respect to y, we are considering only the variables that has y in them. So we have this again, okay, and then the third one. So we'll be having 2 times 6 will be giving us 12. The power of our y reduced by 1, so we are left with y. Alright, now coming here, the power here is 1. So 1 minus 1, we have 0. Y to the power 0 becomes 1. Alright, so y will go, we are left with minus x. Alright, and then our Lagrange multiplier when our y goes, okay, plus our Lagrange multiplier, we still have 0 to be equal to 0 at our turning point, okay. Now I'll also be making our Lagrange subject like I just did here. Alright, so this moving to this side, we'll be having that our Lagrange multiplier is equal to minus 12y plus x, okay. When our 12 goes over the equal to, it becomes a minus. When our minus goes over the equal to, it becomes a plus. So I can call this our equation 2. Alright, then the last, we are differentiating with respect to our Lagrange multiplier. Alright, so when we differentiate this, we'll be going back to getting our constant, our constraint, okay. Now our Lagrange multiplier, we have this and this, right? So when we differentiate, we'll be having our x. When we differentiate, we'll be having our y, and then lastly we'll be having minus 40. Our turning point, our equation is equal to 0. Alright, now if I want to, we can get back to our constraint, right? We'll be having that x plus y, this move over the equal to, it becomes what? A positive 40. Alright, now since I've made Lagrange subject here, we can therefore equate this and this. Alright, because Lagrange is both subject in both cases, right? So we can be having that minus 8x plus y is equal to minus 12y plus x. Alright, from this case, are we there? Now the next thing we're doing is we'll be collecting like terms. Our x will come this side, our y will go over there, okay. Now minus 8x, this is a positive, right? We'll now be having minus x when it comes over. Then we have to be equal to minus 12y. When the positive goes over, it becomes minus y. Alright, now this will be giving us minus 9x to be equals to minus 13y. I can take, since we are both having minus in each cases, I can strike out the minus, right? So we can strike out our minus, and then we'll be having 9x to be equal to 13y. Now from here, I want to make my x subject of the formula, right? So we'll be dividing through by 9. Our x will be equal to 13y over 9. Now we have gotten this, we can now substitute into our constraint. Alright, so our x plus y is equal to 40. Now I'm using 13y over 9 for x. Alright, so we'll be having that 13y over 9 plus y is equal to 40. Right, now this 9, the power, the denominator here is 1, the denominator here is 1, so we can multiply all through by 9, okay, to cancel out our 9, okay. Now we'll be having 13 multiplied by 9, okay, so 13 multiplied by 9, okay, and then the denominator of 9, right? So this 9 will strike out our denominator, we are left with just 13y. Alright, now when we multiply this by 9, since there is no denominator to strike it out, we'll be having plus 9y, and then lastly we'll multiply 40 also by 9. Alright, so we're going to be having what? 360. Okay, now 13y plus 9y, 13 plus 9, we'll be having 22y to be equal to 360. If we want to get the value of our y, we have to divide all through by 22. So when we divide this, we'll be having that our y is equal to 16.3 something, okay? So to the nearest whole number, our y will be equal to 16, okay? Now we'll go back to our constraint that our x plus y is equal to 40, right? Now we have gotten the value of our y, so our x plus 16 should be equals to 40, okay? Then what we'll do now is that we just make our x subject of the formula, okay? 40, this becomes a minus 16. Our x will be giving us 24. So we have gotten the value for our x and y that are going to be giving us what? To be maximizing production cost, alright? So with that, we have come to the end of this video, this class on partial derivative. Don't forget to like our video if you haven't. Subscribe to our channel, share our video with as many as possible. We'll see you in our next class. Thank you.